Hey guys, today we are doing notes on converses and biconditional statements. If you have not done the notes from Monday and Tuesday, please make sure that you get those done before you do this, because this is not going to make sense if you do not. In class, you guys have the sheet of paper to do these few problems. If you are not in class, you need to go to Canvas and find the 2.1 to 2.3 practice and do the problems for the first half of the practice. Okay, you only do like the first whole page and then the problem that's on the back. Okay, so you can pause this and do that. If you are in class, go ahead and look at the answers here. So write the following sentences as if then conditional statements. So on Fridays I get paid. If it is Friday, then I get paid, or if I get paid, then it is Friday. Number 2, our team won the game, so we went out for ice cream. If my team wins the game, then we go out for ice cream. Or if we go out for ice cream, then my team won, or something along those lines. For the next one, you are writing the next two numbers in the sequence, then make a conjecture describing the pattern. So for number 3, 2 to 6, 6 to negative 18 to 54. So I'm multiplying by a negative 3 each time. So I need to get my calculator out. So we have negative 162 and positive 486. And the conjecture would be multiply by a negative 3 each time. For the next one, it looks like we are dividing by 2 or dividing by a negative 2. So 400 divided by negative 2. Negative 50 divided by negative 2 would be a positive 25. 25 divided by negative 2 would be negative 12.5. So divide the previous term by negative 2. Oh, I guess it's there already. Cool. Okay, underline the hypothesis and circle the conclusion. So always hypothesis comes after if, conclusion comes after then. So if you live in Middlebury, then you live in Vermont. Counterexample proving each statement is false. So this would be a false one because there is a Middlebury in Indiana, not just in Vermont. If the sum of integers is positive, then both numbers are positive. So the sum of integers is positive, both numbers are positive. This would be false because if you have a small negative number and a big positive number, you're going to get a positive answer. If this is the month of February, then there are only 28 days. If this is the month of February, would be your hypothesis. There are 28 days would be your conclusion. And this is false because in leap years, like an example, this year we had a leap year. February had 29 days because it was a leap year. Okay, find the 17th term in each repeating sequence. So if we look here, we have EKRT, EK. So we have 1, 2, 3, 4. Remember how we found this? So 17 divided by 4 is not a nice number, but 16 divided by 4 would be. So if the 16th term, and it's because, not 16 divided by 14, 16 divided by 4. If I have a whole number, that means that my 16th term is that last term in the sequence. So then I have to count up to get my 17th term, which would be E. Okay, so then this one, I have 1, 2, 3 terms in this sequence. So if I do, I'm going to have to pause it there. Hold on. If I do 17 divided by 3, that's not a nice number. 15 divided by 3 would be a nice number. So this would be the 15th term. Then I'd have the 16th and the 17th. So the 17th term is -7. So a converse is a conditional statement formed by switching the hypothesis and the conclusion. So basically, all we have to do to write the converse is switch the hypothesis and the conclusion. Go ahead and get that written down in your notes. Remember, if you want to write a couple of these down, if is not part of the hypothesis, then is not part of the conclusion, then the if always stays at the beginning and the then stays after the comma. So here are a couple examples. So our original statement, if today is Monday, then tomorrow is Tuesday. So today is Monday is our hypothesis. Tomorrow is Tuesday is our conclusion. So we're just going to flip those. So it would be if tomorrow is Tuesday, then today is Monday. Make sure to get that written down into your notes. Next example, if you fail your test, then you will have to retake it. So my hypothesis is you fail your test. Conclusion is you will have to retake it. So you need to flip-flop those. If you have to retake your test, then you failed it. Now obviously you're not going to use all of the words that are in there. Sometimes you're going to take some out. Sometimes you're going to add some in. It all depends. So you guys try these, pause it, and write first the hypothesis, then the conclusion, and then the converse for both of these. Once you're done, then you can play it again and get the answers. So if I can save more money, then my allowance will increase. I can save more money would be my hypothesis. My allowance will increase will be my conclusion. So then I would have, if my allowance increases, then I can save more money, or something along that line. Again, I'm not going to be super picky on this, but of course you have to have the if and the then. So if a bird is a cardinal, then the bird is red. So my hypothesis is a bird is a cardinal. Conclusion is the bird is red. So my converse would be if the bird is red, then it is a cardinal. Okay. Symbolic notation. So this is the notation P arrow Q. Notice how this arrow just looks like that because later we're going to use a different arrow. So P is the hypothesis. Whoops, spelled that wrong. And Q is the conclusion. P does come before Q in the alphabet. So if you can remember, P comes before Q, so the hypothesis comes before conclusion. You guys can think if P, then Q. So we have to do a little practice here. P then Q, so if P then Q. So if two lines meet at a right angle, then they are perpendicular. Then if we flip-flop it, we're going to put the Q first and the P second. So if two lines are perpendicular, then they meet at a right angle. Given the hypothesis is two angles have the same measure, the conclusion is two angles are congruent. So if we do P then Q, we'd first have if two angles have the same measure, then they are congruent. If we flip it and do the converse, which is the conclusion then the hypothesis, it would be if two angles are congruent, then they have the same measure. Notice how we're still using the first piece of the conclusion there. So biconditional statements, first of all, a biconditional, oh, I need my pen. A biconditional statement is when both the conditional statement and converse are true. These both have to be true in order to be a biconditional statement, okay? So the requirements for a biconditional statement would be it always uses the phrase if and only if. Now, you can abbreviate that to IFF. I would recommend that you abbreviate it so that you can save some time writing. The next requirement is both the conditional and the converse must be true. And that is the most important one. If they are not both true, so if you have your conditional and then you write your converse and the converse is not true, it cannot be a biconditional. You cannot create a biconditional. The symbolic notation is a little bit different than converse. So it would be P and then a double arrow Q. And then this basically means P if and only if Q. So that's how you would write it. You do your hypothesis first. If and only if your conclusion. Okay? So if the sum of a measure of two angles is 180 degrees, then two angles are supplementary. Think to yourself, is that true or false? It is definitely true, because if two angles equal 180, they are totally supplementary. The converse, then, we're going to flip the conclusion and the hypothesis. If two angles are supplementary, then the sum of the measures of the two angles is 180. That is also true, because supplementary always means that they equal 180. So the biconditional, then, because both of the statements are true, would be the sum of the measures of two angles. So, you know, this is your hypothesis. This is your conclusion. Remember, the biconditional is P if and only if Q. So the sum of the measure of two angles is 180 if and only if the two angles are supplementary. Okay? So the next two I want you guys to try. But keep in mind, so for the A portion, you are just going to write the converse. So do, instead of P then Q, you're going to do Q then P. And then if the converse is true, write the biconditional statement. If the converse is false, write not reversible. So if you write the converse and it does not make sense or it's not always true, you need to write not reversible. So go ahead, I thought I fixed this one. Go ahead and try this. This one already did the converse for you. So if two angles are complementary, then they add up to 90 degrees. So you would flip-flop them. If two angles add up to 90 degrees, then they are complementary. That's your converse. And then B, because the conditional, which is this one, and the converse, which is this one, are both true, we can go ahead and write the conditional, the biconditional, okay? Which would be two angles are complementary if and only if, notice how they have that in there, they add up to 90 degrees. The next one, if I go to Goshen High School, then I live in Indiana. So the hypothesis is I go to Goshen High School. The conclusion is I live in Indiana. Okay, so for A, you write the converse, which you flip your conclusion and your hypothesis. So you have, if I live in Indiana, then I go to Goshen High School. For number two, or for the first one, if I go to Goshen High School, then I live in Indiana, that's true. For A, if I live in Indiana, then I go to Goshen High School. Does everyone in Indiana go to Goshen High School? The answer is no, so this converse is not true. So that means that for my biconditional, I need to write not reversible because my converse is not true. So then going backward, write a conditional statement and its converse from the biconditional. So this would be the conditional, this would be the converse, okay? So the conditional, the biconditional is always P if and only if Q. So this is my hypothesis. This is my conclusion. So for my conditional, I would have if 3 points are collinear, then they lie on the same line. Then for my converse, I'm going to flip those. So you'd say, you could say if points lie on the same line, if 3 points lie on the same line, it doesn't matter. Lie on the same line, then they are collinear. Number 2, a figure is a triangle if and only if it has 3 sides. So this is my hypothesis. It has 3 sides as my conclusion. So my conditional would be if a figure is a triangle, then it has 3 sides. My converse, you flip your hypothesis and your conclusion. So it would be if a figure has 3 sides, then it is a triangle. Then you guys can try this one. So write out the following conditional statements. P, then Q. Okay, notice you need to be careful here with your arrows. So this one is if P, then Q. So you would have if angle A is a right angle, then the measure of angle A equals 90. This one is a biconditional. So you have to use if and only if, okay? You first do P, if and only if Q. So angle A is a right angle if and only if the measure of angle A equals 90, okay? All right, so you guys did the warm-up on that sheet, and now you guys can do the practice problems on the homework page that I handed out. So if you'd like, you can pause it, or you can do the whole page and then come back and get the answers. So we are writing the converse to the following sentence. So if it storms outside, then our game is canceled. So I need to flip the hypothesis and the conclusion. So our game is canceled, or sorry, if our game is canceled, then it is storming outside. And again, you might need to change some words around, change some verbiage around. Number 2, if 4 points are collinear, then they are coplanar. So you could say 4 points are coplanar if 4 points are coplanar, then they are collinear. You could also say if points are coplanar, then they are collinear. For number 3, if 2x equals 10, then x equals 5. So if x equals 5, then 2x equals 10. For this one, so first you're doing P, then Q, and then Q, then P. So if today is Wednesday, then I have wrestling practice. For the converse, you'll flip it. If I have wrestling practice, then today is Wednesday. Same thing here, we're going to just write the conditional, then flip it to the converse. So if angle A and angle B are complementary, then the measure of angle A plus the measure of angle B is 90. Flip it. If the measure of angle A plus the measure of angle B equals 90 degrees, then angle A and angle B are complementary, and both those are true. Okay, for this one, so this is moving on to the practice with biconditional statements. So you want to, for the A portion, you want to write the converse. And for B, if the converse is true, you write the biconditional statement. If the converse is false, write not reversible. So for A, we have, if it is Christmas Day, then today is December 25th. Both of those statements would be true, so we can write our biconditional, which is, it is December 25th if and only if it is Christmas Day. For number 2, if 2 angles are vertical, then they are congruent. So for A, it would be, if 2 angles are congruent, then they are vertical. But is that always true? If 2 angles are congruent, then they are vertical. That's not true, because sometimes you're going to have different angles that are not vertical. So you could have, an angle over here and an angle over here, but they have the same congruent tick mark, which means that they are congruent, but those two are not vertical. Number 3, so this one we're going backwards. You're writing a conditional statement and its converse. So the conditional would be, if a number is even, it is divisible by 2. And then your converse would be, if a number is divisible by 2, then it is even. And both of those are true, because we took our biconditional, which is this, and if we have a biconditional written, both the conditional and the converse have to be true. So number 4, for the conditional, it would be, if today is Valentine's Day, it is February 14th. The converse would be, if it is February 14th, then it is Valentine's Day. Then for number 5, 6, and 7, you are given your conclusion and your hypothesis. So the first one is your conditional, P, then Q. So if today is Thursday, then tomorrow is Friday. You would flip it to do number 6. If tomorrow is Friday, then today is Thursday. And then your biconditional, both of those statements are true, right? So you would say, today is Thursday if and only if tomorrow is Friday. Okay, so make sure that you turn in both pages, you need to take a picture of the front and the back. There are 2 separate places to upload your notes and upload your practice. Make sure that you do both of those so that I can give you points. Hopefully you guys have a great weekend, and I will see a lot of you on Monday and Tuesday, and I am looking forward to seeing all of you in class. Let me know if you have any questions or need help on something.